So what I'm going to do is to go through some antiderivatives like the ones that I gave in the class. Now all these problems are taken from Thomas Calculus with early Transcendental Netherlands 12th edition, your textbook, but they are kind of different from the homework problems, but they are similar to some of the homework problems. So let's take the first one. Now we need to take the antiderivative of 2 minus 5 over x squared. So you can use the sum rule here. You can take the antiderivative of each piece and then subtract them. So if you do that, the antiderivative of 2 of course will be 2 times x, right? But before you do that, you might want to rewrite the 5 over x squared as a and bring the component the exponent above. So this can be written as 2 minus 5, and 1 over x squared can be written as x to the minus 2. So now if you take the antiderivative of that, which is given by big F x, the antiderivative of 2 is 2x minus 5 is a constant, so we leave it as it is. The antiderivative of x to the minus 2 is, you can use the power rule now. Okay, so you add 1 to negative 2, which becomes negative 1, so this becomes x to the negative 1, and you divide that by the new negative 1. Okay, and now you can rearrange and write the x to the minus 1 as 1 over x, so you get 2x. Now there's a negative here, which becomes positive, so positive 5 over x plus a constant c. Alright, so now let's look at this one. Let's look at this one. Okay, so the first thing to do would be, again we have a sum, so we can find the antiderivative of each piece and add the antiderivatives. But before that, it might make sense to just rewrite it. So we write the square root x as what? X to the 1/2 plus 1 over square root x is what? 1 over x to the 1/2, which is actually x to the negative 1/2. So 1 over square root x is 1 over x to the 1/2, which is x to the negative 1/2. So now you want to find the antiderivative of this piece, and then what happens is you can use the power rule there, and then the 1/2 becomes 3/2. So it's x to the 3/2 divided by 3/2 plus negative 1/2. If you add 1, you get x to the 1/2 divided by 1/2 plus c. So now you can take, you can clean it up by taking the 2 right to the top, then it becomes 2/3 x to the 3/2 plus you can take the 2 to the top, which is 2 times x to the 1/2 plus c. So in both these examples, we use the sum rule or the difference rule, and we rewrote it using powers, positive like powers, and then before we actually find the antiderivatives. Now let's look at this, the next one, which is f of x is equal to 1 minus 5 over x. The moment you see 1 over x, you should be very careful. You should not try to write it as x to the minus 1. Why is that? Because for 1 over x, the power rule, so the power rule will not work. The antiderivative of 1 over x is just natural log of x. So please watch out for that. Do not use the power rule when you have 1 over x. So once again you have a difference, so you can take each piece and find the antiderivative. So the antiderivative of 1 is what? X minus 5 times, then you have 1 over x here, and the antiderivative of 1 over x is natural log of x. So it's x minus 5 times natural log of x plus a constant. So now again you have some trigonometric functions here. 13c, you have a sine, and then we have another sign, but you have subtraction. So therefore again you can use the sum difference rule. So you can take the antiderivative of each piece. Now what's the antiderivative of sine of pi x? Well, the antiderivative of sine of pi x is negative cosine pi x. Because why? Because the antiderivative of sine x is negative cosine x. So pi x is cosine pi x. But when you differentiate pi x, you get an additional pi, which is not here in this. So you need to get rid of that pi. So immediately you divide by the pi. So it's negative cosine pi x divided by pi minus 3, and then you have 3 here, and then if you try to differentiate this one, sine 3x, once again, you have negative cosine 3x, okay, and you need to divide by 3 to get rid of that additional 3. Right now, so then you have, there's a 3 here already, so that 3 will cancel off with this 3. And if you clean it up, you get negative cosine pi x over pi, and then plus 3 cosine pi x. Let's move on. How about this one? Now you have secant squared. Now secant squared is a very familiar antiderivative. Why? Because the derivative of tangent x is secant squared x. The derivative of tangent x is secant squared x. So then the antiderivative of secant squared x is tangent x. So therefore you can think of the antiderivative of secant squared 3x over 2 as tangent 3x over 2. But once again, if you differentiate this, you will get an additional multiplying by 3/2 factor. You need to get rid of that factor by dividing. So the answer is not just tangent 3x over 2, but tangent 3x over 2 divided by 3 over 2, and there's a minus. You can bring this over to the top, and then you have negative 2/3 tangent 3x over 2 plus c. Let's go to 19c. We have f of x is equal to e to the x over 2. Now the integral of the derivative of e to the x is e to the x. Therefore the antiderivative of e to the x over x is what? E to the x. But we have e to the x over 2 here. In other words, we have e to the 1/2 x. So the antiderivative will be, you repeat it, right? Okay, so e to the x over 2, but you have that additional 1/2 which you need to kill, so you divide by 1/2. So remember that the integral or the antiderivative of e to the x over 2 is e to the x over 2, and whatever the coefficient here, you divide by that. And now you can clean it up by bringing the 2 forward, so you have 2 times e to the x over 2 plus c. Now here this is also an exponential in this problem, but the base is not e, the base is 2. Now for this you can use the formula, okay. So in the table you can see a formula called the integral, where they find the antiderivative of a to the kx, okay, and the antiderivative of a to the kx is actually 1 over k natural log of a to the kx plus c. That's the answer if you have a to the kx. But here a is like 2, okay, so it's like 2, and k, so actually this is actually I think I should write there, this is the antiderivative of a to the kx. So the antiderivative of a to the kx is actually 1 over k natural log of a to the kx plus c. Now in this case, what is a like? A is like 2, the base. What is k like? K is actually the coefficient, which is what? Minus 1. So when you plug in a equals 2 and k equals minus 1, you get the antiderivative f of x here as 1 over, this is minus 1, and then natural log of 2, because a is 2, a to the a is 2, so 2 to the k again is minus 1, so 2 to the minus 1 times x, which is 2 to the minus x plus a constant. Well, you can rewrite this a little bit by writing 1 over negative 1 as negative, right, and then you have 2 to the negative x and divided by, there's a natural log of 2 here, plus c. So remember, this is when you have a different base other than e, this is the antiderivative. But if you just have e, then all you need to do is to repeat it and divide by the coefficient here. Okay. Now these problems are the same as the previous problems, except that now we are using the indefinite integral sign, right? Okay. So this is the indefinite integral sign, okay, and now we want to find the indefinite integral of this. Once again, it's just finding the antiderivative, so no big deal. So we can take one piece at a time and do it separately, because there's a difference and a sum. So what's the antiderivative of 1/5? it'll be 1/5 x. Well, you might want to write the x 1 over x to the 3 as x to the negative 3. So it's negative 2 times x to the negative 3 plus 2x. And now you can find the antiderivative or the indefinite integral, right, as you can say in this case, right? So it's 1/5 x minus 2 times what's the antiderivative or the of x to the minus 3. So you add 1 to that, that becomes x to the minus 2, and you divide by minus 2 plus 2 times you add 1 and the x becomes x squared divided by 2. Well, you can clean it up a little bit, right, but I'll leave it you to clean up. So you can cancel off the negative 2 and negative 2 and then bring the x down. You can cancel off the 2 here also, right? And so, but I will leave that to you. Okay, now let's go to another problem. Now here we have a quotient. Now remember that in antiderivative, when you are trying to find the indefinite integral or the antiderivative, there is no quotient rule. There is no product rule. So then how do you do this? If there is no quotient rule, if there is no product rule, you should not try to find the antiderivative of each piece and divide them. That is completely wrong. What you should do is you should try to split it. So what I have done is I have split the 4 over t cube as one part, and then I split the square root t over t cube as the other part. Now I can rewrite this. Then I can write this as 4 times 4 over t cube is 4 times t to the minus 3 dt. And this can be simplified, and that's what? T to the 1/2 divided by t to the 3. So if you subtract the exponents, you get 1/2 subtract 3. So 1/2 subtracts 3 is what? It's negative 5/2. So you get actually negative 5/2 here. So when you have a situation like this, always simplify before you do anything. Now you can use power rule easily for this, right? Okay, so when you use the power rule for this 4 times, t, this becomes negative 2 divided by negative 2, and this becomes t. Negative 5/2 plus 1 becomes negative 3/2 divided by negative 3/2, and you can clean it up by bringing the t negative 2 downstairs, right? And then you can take the 2 here up and 3 is still there. You can bring this down as a positive exponent and say t to the 3/2 plus c. Now if you look at number 50, this looks kind of weird, but actually if you think about it, this is a very familiar antiderivative. And it's very familiar derivative, so you can very easily find the antiderivative of this. You can also check it out from the table, but it's good if you can kind of memorize this, right? I mean, do you guys remember what the derivative of secant theta is? The derivative of secant theta is secant theta tangent theta. If the derivative of secant theta is tangent theta secant theta, then what is the antiderivative of secant theta tangent theta? Secant theta, because when you differentiate secant theta, you get this, so the antiderivative of this will be this. So it's very simple. The answer is 2/5 secant theta plus a constant. Now let's finally to end this up, let's do a different type of problem. Now we want to, this is an initial value problem. So you're given the second derivative of y as this, right? And the second derivative of y is given. At the same time, two initial conditions are given. Y of 4 is 20 and y prime of 4 is 7. So first of all, you have the second derivative. So you want to get at y, remember, that's the target. But to get at y, you need to first differentiate, find the antiderivative once and get the first derivative. And then once you have the first derivative, you evaluate the constant. And once you evaluate the constant and have the first derivative ready, you find the antiderivative again. And then you should get y and another constant, and finally you evaluate that constant. So you start by finding the antiderivative once. So if you find the antiderivative of this, right, what do you get? So you have 3 times x to the negative 1/2. You can easily use the power rule, and the negative 1/2 becomes positive 1/2 divided by positive 1/2. 3 is still there, plus c1. So if you clean this up, the 2 comes to the top, you get 6x to the 1/2 plus c1. But you cannot leave it like that, because now this is an initial value problem. You have to find out what c1 is. So how do you find that? You look at the initial conditions. Now you are still with the first derivative of y. So the initial condition for your use would be this one, which involves the first derivative. So what you do is, we are told that if you plug in x equals 4, the first derivative's value is 7. So what you do is you plug in 7 here, okay, 7, and then you have 6 times the first derivative. So you plug in x, right? Okay, so because x is 4, right? Plug this in, right? So 7 comes, the derivative is 7. 6 times x is 4, 4 to the 1 half, 4 to the 1 half, plus c1. Now this can be written as 7 equals 6 times, what is 4 to the 1 half? That is 2. So 2 plus c1. So c1 is equal to 7 is equal to 12 plus c1, which will give you c1 is equal to, take the 12 over to the other side, you get minus 5. So c1 is equal to minus 5. So now make sure that you go and plug that back in. Okay, so you plug that back in, right? What you get is you get dy over dx is equal to 6x to the 1 half minus 5. But you're not done it, because the whole idea is not to find dy over dx. That's the first antiderivative. You need to find the second antiderivative, which will give you y. So from dy over dx you need to get to y. So you differentiate, you find the antiderivative again. So 6 stays as it is. We'll find the antiderivative of x to the 1 half. You can use the power rule again. You get x to the 3 halves divided by 3 halves minus the antiderivative of 5 is x, 5x plus c2. Now how do you find c2? You look at the other initial condition, which is what? Y of 4 is equal to 20. That means if you plug in x equals 4, y is 20. So y becomes 20, right? Y becomes 20, right? Okay. And 4 times 20, 4 times x is 4, so 4 to the 3 halves minus 5 times, what is x again? 4 plus c2. So you get 20 is equal to 32 minus 20. So 4 to the 3 halves is what? 4 to the 1 half is 2, 2 to the 3 is 8. 8 times 4 is 32 minus 20 plus c2. So 20 is equal to 12 plus c2, so c2 is equal to 8. So now you just go up here and plug in that 8. So what do you get? Y is equal to 4 times x to the 3 halves minus 5x plus 8. 4 times x to the 3 halves minus 5x plus 8. That's the answer, but you need to find y. Alright, so that's it for this video, right? Okay, and so good luck, and enjoy the homework assignment.